Hey guys, and welcome back to episode 2 of my Flutter architecture series. Today we'll go over the 4 most common scenarios when building an application using this architecture. In this episode, instead of building an application with all of the UI code involved, I will specifically go over 4 scenarios that's commonly been asked about in the comments. So please, if you have any questions, please ask it in the comments or over on the Slack channel where I can see and respond to these questions. In the first video, I showed you how to do the basic view to view model binding and rebuild your views when the state of your view model has changed. Today we'll talk about a concern more than an implementation detail, and that is partial view rebuilds. The second thing we'll talk about is rebuilding view model A when view model B has triggered a change in a service. The third one is to get data from a future, and then the second one is to show data from a stream. The last 2 points is actually not something that people have been asking for because it's quite easy to do and I use it in a lot of my videos. It is mostly there to show how Stack has now removed some of the boilerplate involved with doing those 2 things. So before we move on, I want to ask you guys what you'd like to see next. Please leave a comment below and choose between unit testing your view model using a kind of TDD approach and a deep dive into services around what it is, how it's used, and when to use a service. Now, if you didn't follow along with the tutorial, you can go over to FilledStacks.com and open up part 2 of the architecture tutorial, and then under the thumbnail you'll see a download code button where you can download the code we're going to start using in this tutorial. Once that code is downloaded, you can open it up in Visual Studio Code or in your editor of choice. We'll navigate to the pubspec.yaml file and we'll make sure that all the packages are downloaded before we start. If the code in this file doesn't look familiar to you, please watch part 1 of the series and then come back to this video afterwards. The first thing we'll do is partial view rebuilding. So under the views folder in the UI folder, we'll create a new folder called partial builds. Then under that folder, we'll create a new file called partial builds view, and we'll create another dot file called partial builds view model. For the view model, we'll simply create a new class called partial builds view model. This will extend the base view model from the stacked architecture. For the partial builds view, we'll import the material package and then create a new stateless widget called partial builds view. And for the body of this widget, we will create a new view model binding by using the view model builder and passing it in the type partial builds view model and using the non-reactive constructor. So as a quick note, you can see that there's 2 imports that it shows for you when you want to import the view model builder. In the latest version of Stack, we've updated that and moved all of those files into the source folder. So head over to the pubspec.yaml file and we'll update Stack to the latest version 1.4.3 because I also update Stack while I'm building this video. So you should update yours to 1.4.3. Now if we get back to the partial builds view, we'll create the builder for the UI. We'll supply it with an anonymous builder function that takes in the build context and then the model and then a child widget. For this function, we will return a scaffold which will represent our view. Then for the body of the scaffold, we will set it equal to a column. And for this column, we'll set the main axis size to max. And then we'll also set the main axis alignment to center. And then we'll supply it with an empty children widget for now. Then we can go ahead and for the view model builder, we can supply a function that returns a partial builds view model. And that's basically the first step to creating a partial building view is by using the .non-reactive constructor. That will make sure that the builder only gets called once. So this is a verbose version of doing this where every widget on screen I will make it inherit from the view model and either react or not react. In this case, we'll just have a simple text form on the screen, and when you type in something, there's going to be a separate widget that reacts to that while the rest of the widgets don't rebuild. So you can create a new stateless widget and call it string form and make it private. This widget will extend a third-party version of the ViewModel widget called hook ViewModel widget, and it will take a type of partial builds ViewModel. So you can head over to the pubspec file, and then we'll add a new package called stacked_hooks. This is a very simple package that uses the hook widget and then creates a different widget that fetches our view model and provides it to us through the build function. Back in the partial builds view, you can import the hook widget, and then we'll pass it a value in the super constructor. We will set reactive to false. The constructor is not a const constructor. Don't ask me why, I just didn't think about it, but I'll update that after this video. Then you can update the build function name to build view model widget, and then there's a second parameter that you have to pass in, which is the type of partial builds view model, and we'll name that model. This now allows you to use hooks in your build function along with the view model widget. Using a hook for the text editing controller is my default way because I don't have to create a stateful widget just to contain a text editing controller. Head over to the pubspec.yaml file where we will add the Flutter hooks package as well. Then in the build view model widget function, we can now create a new variable called text, and we'll call the use text editing controller function for that value. The body of this function will be a text field that takes in the controller text that we had just created. And for the onChanged function, we will call model.updateString. This function doesn't exist, so you can use the quick options by pressing Ctrl full stop or Command full stop and selecting create function. This will create an update string function in your partial builds view model. Then we'll add a private value called title that is of type string, and we will also expose that title through a public property called title. For the body of the update string function, we'll simply set the title equal to the value, and then we'll call notify listeners to rebuild the view. Then you can head back to the partial builds view where we'll use the string form widget that we just created. This widget is set to not react to any of the notify listener calls. This behaves the same as the non-reactive constructor on the view model builder. And so just to show you how often the view actually gets rebuilt or the widget gets rebuilt, we'll print out string form rebuild in the builder function for the string form widget. We'll do the same for the builder function of the partial builds view. We'll convert it into a function and return the scaffold. Once we have that function created, then above the return statement we can print out partial builds view rebuild. Then you can head over to the main file and we will comment out the initial route property for testing only, and we will set our home property equal to the partial builds view. When you see this build error in the console, it is because the get version is still on the old version. Now since we are only using get through the stacked services, I've updated the get version and pushed that. So you can go to the pubspec.yaml file and you can update the stacked services to version 0.2.3. There's also a new command that the pub and dart team has created, which is flutter pub outdated. When you run this command, you will see all of the packages that are out of date and can be updated to a later version. And if you want to automatically update all of these packages, you have to run flutter pub upgrade. And if you run the code now, you won't see anything fancy. You'll basically just have a full width text view on screen. And if you type anything and you open your terminal window and go to the debug console, you'll see that the partial builds view was rebuilt once when it started, and the same for the string form. And as you type, you see that nothing is rebuilt, even though we are calling notify listeners in the view model specifically for that view. So let's get to the actual part where we are now going to build a widget that will react to the changes in that view model. We'll create a basic widget called title and value, and this will extend the view model widget from the stacked package. This view model widget expects a type, so we'll pass in the partial builds view model. When you inherit from this view model, the build function will now expect a second parameter of type partial builds view model that returns the model that you are listening to. you can set the reactive value on the super constructor to true, even though the default value is true. I just want to show you that. And then for the body of this build function, we'll return a column where the first child will be a text widget. This widget will show the title value from the model, and if that value is null, we'll just show an empty string. Then we'll just set a basic style for the text widget and we'll increase the font size to 40. Now I was supposed to actually add the integer value of the text for the title within that column. That's why we had a column, but I forgot. So we'll just have a text for now. Then you can add the title and value widget into the partial builds view builder under the string form widget. And to show the rebuild process of title and value when it is reactive, we will print out at the beginning of the build function title and value rebuild. Now when we restart this code, you should see all three widgets being rebuilt and printed, which is partial build, string form, title and value. And only the title and value should be rebuilt and displayed on screen when we start typing into the keyboard. Once you start typing anything, you'll see that the title value updates and it reacts to the value, but only the title and value is rebuilt for that specific widget tree. This is the structure you can follow for partial rebuilding if you are concerned that you are building very large widgets that might be too expensive to rebuild continuously. And that is it. That is how you partially rebuild a view listening to the same view model. The next example I want to show is one of the most common scenarios that the first version of the architecture didn't make any provision for. This is the scenario where ViewModel A will update a property in a service that ViewModel B is listening to, but ViewModel B won't know that it changed, so it won't update itself. You can create a new folder under the views folder called the reactive example. And before we continue, a lot of the comments mention that they want to see me write all of the code instead of me putting in this code. So I'll put a setup banner on the screen so that you can see all of the setup, because the actual implementation is only about 7 lines of code, but we need quite a lot for the setup so that we can see the example and what it actually solves. So once that banner is gone, that's the actual solution that I'm showing. And to avoid rewriting all of the same code, we will copy the view and the ViewModel file into the reactive folder and change the names to reactive example view and reactive example view model. Then we can go ahead and rename everything to reactive example instead of partial builds. We'll do the same for the view file as well. We can delete all of the code that we will not be using. And then for the body of this view, it will just be a basic scaffold. For the body of the scaffold, we will set it to a center that will take a child of a row. And in that row, we will have our first view model called single increase counter. Then we'll put a sized box with a width of 50. Then we'll add a second widget called double increase counter. So usually I would only have a widgets folder that contains all of the widgets. But in this case, with this architecture, we do have widgets that have its own view models. And so the way that I'm making a distinction between those two types of widgets is by creating a folder called smart widgets, which are widgets that will have its own view model, and dumb widgets, which are the normal expected Flutter widgets that just takes in something and builds itself based on the values provided. So under the UI folder, create a new folder called smart widgets. Then inside of that folder, create another folder called single increase counter. And in that folder, we'll create two files, one to contain the UI code, which is going to be called single increase counter, and the other one that will house the view model, which is called single increase counter view model. For the single increase counter widget, we'll create a new stateless widget called single increase counter. This will return the view model builder as the body of the build function. And for the builder function, we'll provide it with a function that takes in the build context, the model, and the child. It will return a gesture detector. And for the onTap function, we will call the update counter function on the model. And for the child of the gesture detector, we will set it equal to a container. We'll give it a width and a height of 100. We will set the color of this container to blue. We'll set the alignment to center. And then for the child of this container, we will give it a column. The main axis size of this column will be set to minimum. And then for the first child in this column, we will set it equal to tap to increment counter. Then we'll set the text align of this text widget equal to center. And for the second text widget, we will pass in model.counter and call the toString value on it. And we forgot to add the type of the view model. So for the view model builder, we'll add the single increase counter view model. Then we can head over to the view model file for this widget and we can create a new class called single increase counter view model. This will extend the base view model. Then back in the single increase counter view, we will supply the view model builder and give it a function that returns a single increase counter view model. Then we can create the update counter method. We can also use the quick options and create the getter for the counter property. The value for the counter property will come from a service that will be shared between both view models. The service will be retrieved through the locator using the type of counter service. Then we can update the property getter of counter to return a type int, and the value of counter will return counterService.counter. For the body of the update counter function, we will call the increment counter function on the counter service. Once the value has been updated, we'll call notify listeners to rebuild our view widget. Then we'll finish up the UI. So we'll copy and paste the second widget and we'll rename everything for that widget to double increase counter. We'll do that for the folder. Then we'll rename the view model file to double increase counter view model. We'll rename the view file to double increase counter. Then we'll go into the view model file and rename the actual class to double increase counter. And we'll do the same for the single increase counter. Then we'll add the slight differences, which is the text that will say tap to double counter. And in the double increase counter view model, instead of calling increment counter, we'll call double counter on the counter service. Next up, we'll create the basic counter service that will house our actual counter. You can create a new file under the services folder called counter service. This will have a class called counter service. And inside of that class, we will have a private value called counter. This counter value will be exposed through a public getter called counter. And then we'll create a function called increment counter. What this will do is increment the counter value. Then we'll create another function, and what this will do is multiply the counter value by 2. Since we are using injectable, I will annotate my class with the lazy singleton annotation. Then I will call on the build runner to generate all of the new code. That can be done by calling Flutter pub, then calling the run action, passing it the build runner, and then the build function along with a flag that says delete conflicting outputs. For the guys and the gals not using injectable, you can go to your locator function and you can call register lazy singleton and pass it a function that returns your counter service. Then you can go over to the view models where we can now import the counter service. Back in the actual view for the reactive example view, we can now go ahead and import our widgets that we have created. Then you can open up the main file and change the home value from the partial builds view to the reactive example view. And just to make things a bit clearer, we'll change the color of the double increase counter to yellow. And finally, the setup is complete. I would usually do all of that off screen and then give you the code so that I can only show you the solution, which is what was keeping my videos nice and short. But since a lot of you are saying you don't know how to follow along, I'm showing you all of the boring parts as well. So if you click the increment counter container now, you'll see that it increments the value and updates it in the UI, but the double counter is not reflecting the current counter value from the exact same service. So if you look at the double increase counter view model, we know that it's reading the same value from the counter service, but it's not being updated. As soon as we tap on it though, we'll see that it updates and doubles the value, but now the blue one doesn't update. That is the problem that we are going to solve in the next few lines of code. The stacked package provides you with a reactivity set of functionality. This is done by using a package called observable-ish, and the only reason I was using this package, even though it's outdated and it hasn't been updated in a very long time, is because it gave me the exact same functionality that I was building for the stacked package itself. So go to the pubspec and add the observable_ish package. Basically what I wanted is to still maintain the same code for my service, but just wrap the values that I want to be reactive in some kind of object and then have it be able to be listened to and reacted to. This package is very old and I'm the only one that likes it. So this functionality might be rebuilt in the stacked package itself, but for now, this provides all the functionality that we need for a reactive service. So finally, onto the implementation, and I don't like making the videos this way, so I'm going to go back to writing all of the boilerplate code and the setup code so we can just focus on the solutions. The first thing you want to do to implement the solution is to make your service reactive. What that means is you want certain values on your service that when changed should trigger a notify listeners in whatever view model is listening to it. The first thing we do for that is to extend it with the reactive service mixin. The second thing we do is to change the type of the value that we want to react to and wrap it in a RX value object of the same type. And to initialize, we'll construct an RX value object of the same type. And then everywhere where the value was being used, we'll now just index into the RX value object and use the value property on it. Now, after you've updated the property that you want to be reactive, we will call a function that's provided through the mixin called listen to reactive values. This takes in a list of reactive values that the service will call its listeners on when it has changed. That's it for the service, and so now we have to make our view models reactive. There's a base view model type called reactive view model. When extending from this view model, you have to override a property called reactive services that expects a list of services to react to. Within this list, we will now return the counter service. You can go to the double increase counter view model and you can extend from the reactive view model. Then you'll create the override for the reactive services list and you'll return the counter service as the only object in that list. Now keep in mind, this is the first implementation. There's a lot of things that I want to add, like making sure that we only react with the rebuild if the value that we're listening to in this view model has changed. But that's it for the reactive view models and services solutions. It's 2 lines that you change in your view model and it's 3 lines in your service, plus the amount of lines that you would need to add the dot value index for where you are using the current value. If you click on the left one now, you'll see that they both update, and the same for clicking on the right one. The next few things I want to show you is just some functionality where Stacked removes some of the boilerplate code for handling futures and streams. Create a new folder inside the views folder that's called future example. We'll copy the partial builds view and view model files again. We'll paste that in the future example folder and rename to future example view and future example view model. Then we'll go into the files and change the words partial builds to future example. Then we can delete all of the widgets that we won't be using as well as the body of the build function. We'll change the view model as well. And for the body of this view, we will return a view model builder that builds a future example view model. To keep things simple, we will return a scaffold as the body of the builder, and for the body of the scaffold we'll return a center widget. For the child of this widget, we'll check if the model is busy. If it is busy, we'll return a circular progress indicator, and if it's not busy, we'll display a text widget, and the value for the text will be from the data property on the model. Then we can supply a function to the view model builder that builds our future example view model, and that is the setup done for this specific example. If you now open up the future example view model, you will see that we have a future ViewModel base class that we can extend from, and it expects a type of the data returned from the future. It is also required that we override the future to run function. You can write your future code directly into this function, but to simulate how it's going to be used with the service, I'll write the future function separately and then supply it to this future to run function. So how we'll do that is we'll create another function that returns a type future of type string, and we'll call that getDataFromServer. We will mark this function as a sync, and the first thing we'll do is we'll just delay the function for a few seconds to simulate an actual server request from an API. And after this delay, we'll return a string, and the value can be set to fetched from server. Then for the future to run function, we'll simply return the function getDataFromServer. There's a few things that this ViewModel does automatically for you. It will set the ViewModel to busy while it's running that future, and when it's returned, it will store the results of your future in a property called data, which you can then access from your view. So if you look at that data, you'll see it is from a file called single source ViewModel, and it has the error. It also has a property called data ready, as well as the busy functionality. If you head over to the main view and set the home equal to future example view, if you run this code, it should show the busy indicator for 2 seconds and then show you the data returned from your future. One other thing I want to show you that these ViewModels take care of is the error handling. So instead of returning a string value, we will just throw an exception with a string message as the parameter. This ViewModel provides you with an override function called onError, where you will receive the error message that's been thrown by your future. This is where you can show a dialog if that is how you handle your errors. Or if you want to show it in the UI, we also store a value called hasError for the specific ViewModel. That can be used and switch on to show different UI depending on the error. For this specific implementation, we'll swap out the entire screen to show a red container with some text that says you have an error. When you run this code now, as soon as it gets to the exception, you'll get your breakpoint if you have your exceptions breakpoint enabled, and that will then show you the error UI instead of the normal UI. If instead you want to have a verification message that acts to your ViewModel's rebuild functionality, you can do what we did earlier by creating a separate widget that inherits from the ViewModel provider and takes in the ViewModel that you want to listen to. We can create a stateless widget called error message, and we can give it a type of future example ViewModel. Then we'll update our build function where we'll get the future example ViewModel as a parameter. You have to make sure that your version of Stack is on 1.4.3 because I added the functionality during the recording of this video. Then if you go back to the widget that we were busy creating, for the text value, we can now return the message from the error object on the model. And instead of always returning this value, we will check if the model has an error. If it does, we will return this specific text. And if there's no error, we will return an empty container so it doesn't take up any space. Then we'll wrap the text that displays our data in a column, and we'll set the main axis size to minimum. And then for the model.data, we will now supply a no data string if it is null, and then underneath that we will display the error message. And if you run this code now, you should see your error message showing up underneath your text. The cool thing about this is that the error message is a reactive widget that can be used as a normal widget anywhere else in this view where this ViewModel is provided. So for instance, if you want a different widget to show your error message, you can just place it in there, and whenever there's an error, it will display it. The next ViewModel functionality that I want to show is the same functionality as the future, but for a stream. We'll copy the future example folder and paste that in the same file, and we'll change the name of everything to stream instead of future. For the stream example ViewModel, you can delete all of the code from the future example ViewModel. Then we can change the extended type to stream ViewModel and implement the property getter stream. Then you can remove all the UI that's in the child of the center widget, and we'll change that to text that will display the title from the model. Back in the stream example ViewModel, you can now create a title property that will return text that says this is the time since epoch, and it will display the data property from the stream view model. Then we'll create a function that will return the epoch time in seconds. The function will return a stream of type int, and while this is true, we'll perform a delay and give it a duration of 1 second, and then after that delay we will yield the datetime.now value, and we'll index into that and return the millisecond since epoch property. Then we have to make sure that the type of the stream view model matches the type of the stream, so we'll change that to int, and we'll supply the epoch updates function as our stream. Then you can head over to the main file and update your home property to stream example view. And if you run this code now, you should see your stream just updating values on the screen. It's nothing fancy, but it takes away a lot of the boilerplate code that we used to write to subscribe and unsubscribe from streams. The stream view model also has some functions that you can override, like onData and onSubscribed. You can also override the transform data, where you can change the data coming in and then use that as the data for your data property. So you can just override the onData property, where you can then use this value passed in and store it locally for any other functionalities you might want to do. The transform data override is called before the data is set and notify listeners is called, so you can make changes to your values in here and then return that as the value that you want to see on screen. The last thing we also want to show is how to switch streams at runtime. For the setup of this functionality, we'll create a boolean called other sources that's private, and we set it to false initially. Then we'll create a function called swap sources, where we will set the other source's value equal to the opposite of the current source value. Then we'll copy our epoch updates function and we'll change the name to epoch updates faster. We'll then change the duration of this delay to milliseconds and give it a value of 300. For the stream, we'll simply check the other source boolean, and then we'll return either the epoch updates or the epoch updates faster function. And then for the main functionality, when we swap our sources, all we have to do is call notify source changed. This will dispose of the current stream subscription and resubscribe to the new one. To test this out, you can go to the stream example view and we'll add a floating action button. For the onPressed function of the floating action button, we will call the model.swapSources function. If you run the code now, it should start out showing the values changing very quickly, and once you swap those sources out, it'll go back to the 1 second delay function. The future view model as well as the streams view model has a multiples version, meaning you can have a view model that listens to multiple streams and rebuilds when either of those streams are changed or returned. You can do the same with futures as well. This is probably one of my longest videos, so I'm gonna stop it here. I want to ask you guys what video you'd like to see next. You can choose between the unit testing approach using this architecture or a deep dive into services. So we'll cover when to make a service, what you create services for, and why they exist. Please leave a comment below or go onto our Slack and chat to me over there on what you'd like to see next. Thank you for watching, and I'll see you guys next week.